Welcome back. This is the solution video for question 4 in our 9-question, 2.5-hour midterm exam. Feel free to see the prior video if you want to know how I set up this test and my approach toward grading in a way that encourages rather than discourages students to conquer tech challenges. Here's question 4. Now in question 4, students attach a NeoPixel strip and a potentiometer to their Circuit Playground Bluefruit devices. If the potentiometer is at position 0, then a single NeoPixel light should light up at position 0. That's the position closest to the alligator clips in the CPB, but dialing the potentiometer should move the single light to the next pixel until it reaches the final light at the end of the light strip when dialed all the way clockwise. Now dialing back should move the single light backward. This is what the build should look like when properly completed. And here's one way to solve the problem. So in this build, we need to import board, NeoPixel, and time, but we're also going to import analog in from analog IO because that's what we need to set up our potentiometer. And down here, we use analog in to create our potentiometer. I'm going to call mine potentiometer, and it's clipped to pad A3. I asked all of our students to use this as the standard so that I could easily grade their work by loading hardware on only one build that I use. So all answers will be the same setup. And one thing that hopefully all my students were aware of, you have to clip your power to 3.3 volt, not V out. If you used V out, then you would get the wrong readings at the high end of your potentiometer values. So this is how we set up our light strip. We call it strip, we clip it to pad A1, and we've got 30 NeoPixel lights in the strip. Now we set up colors, black and blue. And then there are a couple of approaches to solve this. And I'll show you what most students did, but then I'll show you a better approach, which I've commented out below. So our potentiometer values range from 0 to 65,520, and our lights are from 0 to 29. So we need to convert our pot reading to a number from 0 to 29. Now many students use the calculation like this. Dial underscore value is the pixel number that you want to light up, so it's the number of the LED light in the strip. All other LED lights should be black, they should be turned off. Now this number should be a number from 0 to 29. Take our maximum pot value, divide that by the number of the lights in the strip, and divide your pot value by that value. Now that'll give you a number to use, but if you print out the dial value, which is the number of the LED to light, and the pot value, you'll see that the values don't always work out. At the very high end of the potentiometer readings, you sometimes get a value of 30, and we don't have a light that's numbered 30 because our lights are numbered 0 through 29. If you did that, you would see the last light would flicker on and off. It's trying to turn on a light 30, but there is no light 30, so that's why all the lights are off. Now, as I mentioned in videos and in class, it's really useful to use print statements to find out what your code is doing. You didn't need to include a print statement in this solution, but the print statement here will show the LED light and the potentiometer value, and it would give you a heads up if you were running into some calculation problems. And if you did this, even if you didn't catch the potential problem in the calculation above, you'd notice that 65,520 was giving you a reading of 30, and you didn't want that because there's no LED 30. Now, some students compensated for this using if statements, and that was great. But I also want to give you a heads up that there can be an issue if you use int to work with fractional numbers. And I covered this in a subsequent CircuitPython video as well. So there are a lot of approaches to fix this, but here's what I think is the best approach. So if you're taking the retake, use the approach below that I've commented out here. Now this is the same calculation, but look what we do here. We put the strip num of lights -1, so we get a maximum value of 29, but by using round, we also make sure that we get a clear 0 value for the first few values of the pot reading, as well as stopping at 29, so we don't get that flashing at the end. And this is going to work great. It's going to give us a dial range around the 0 position through the 29th position. We could tinker a little bit more with the ranges around 0, but this really is fine and it works very well. Now many students also use this approach to moving the pixel forward, and that was totally fine. You got credit for this. They loop through all of the lights from 0 to num of lights. Remember how for loops work. We start at 0 and we never get up to 30. We stop at 29, which is good because our lights are 0 indexed and they go from 0 to 29. And then if the value in the index that we're going through in the loop equals dial value, then that light is turned blue. Otherwise, we turn the light black and shut it off. So that works great, but we didn't need to use the for loop. We could save ourselves a few lines of code. Look what I've done down here. You could just turn the entire strip black, and since the CPB executes so quickly, we could then right away turn a single light to blue. No loop required. This happens so quickly, you'd still get the great effect of the light moving forward or backward as you dialed your potentiometer. So if you do the retake, consider using this as well. Either one is okay though. So that's the 4th question. Question 5 is in the next video.